Welcome to Main and 5W channel in a very interesting topic today from architectural point of view, innovation point of view. Basically, we'll talk about sharding. I would start with something with Oracle, but I will take you through a lot of different solutions where sharding is used. I personally have used this concept for scalability, a lot of use cases. I'll also share some of the thought process there. So if you really see what is Oracle sharding or any sharding concept, you can really see that how an unsharded table in one database looks like in a server. And when you shard the table in three database, how it looks like server A, server B, server C. Okay. So let's jump into understanding about Oracle because Oracle database is one of the very mostly used database globally. We all know. We'll talk about that. Then we will switch over to the other solutions. So from an architectural perspective, there is an unpartitioned table here, which you can see customer ID, customer name and amount. And you're creating three shards, shard 1, shard 2, shard 3, where you have different customer IDs and different things in parallel. Okay. Now a data tier architecture, data is horizontally partitioned across independent databases. Okay, this is horizontal table partition in sharding. So data is horizontally split across the sharded table, same columns, subset of rows. Please understand, very simple, right? So customer ID, customer name, amount will not change, but the rows have changed. You can have multiple sharded database, each in a dedicated server, own local hardware. They shared nothing between the shared databases, different architecture from the rack. So when I talk about rack, we're talking real application cluster from Oracle. From an application point of view, there's a logical group as a single database, data partition transparent to the application. So the user who maybe is writing a programming language, writing a Python code, Java code, programming language code may not really see the sharding from his view. Okay. Coming back to the architectural perspective for a while, but we will go very detailed into it in an architectural session. But here I just wanted to give you a perspective. A single logical database horizontally partitioned across a pool of Oracle database, which is called shards. What is a shard? It's an independent physical Oracle database which hosts a subset of the shard database. It will use local resources like CPU, memory, disk, shared, no hardware, software, replicated for high availability or DR with Oracle replications, same region for high availability, different region for DR. You will use the GSM, which is a global service manager, or a shard director, which route connection based on the database roles, load, replication, lag, locality. And you have a shard director, specific implementation of GSM for sharding. And you can deploy multiple shard director for HA purpose. Now, if you really see where will you use this sharding in Oracle, right? Now, this is common for most of the database, but we're just trying to be very specific here for a while for Oracle, okay? First thing, linear scalability. So you can linearly scale the performance, isolating availability and performance issue in a shard. Second, fault isolation. Sharing nothing architecture between shard isolates the availability performance issue maintained within the shard because they are very independent. Supports HA, DR between the shards, data dependent routing, automatically routines connection to proper shards. You can have geographical distribution, simplified deployment and lifecycle management. So applications like OLTP or well-defined data model data distributions can really use shards. Okay. We also have used some of these concepts in data science and some applications which needs a really large volume of data to be picked, quick response time, blah, blah, blah. So from a specific database perspective, 18C, we all know there is 18C, 19C, and there is also a 20C, which is not, which is just getting into production, but we'll talk about two versions of Oracle. From 18C, you can do user-defined sharding. 12C are to introduce system managed sharding and composite sharding. 18C the user defined sharding. So you can actually custom make your sharding structure. Second, PDB sharding, allowed to use PDB as shards or catalog database. 18C supports shard as a single PDB in a given PDB. A CDB can contain other non-shard PDBs also. You can do rack sharding, which is very interesting, enable to logically affiliate table partition to the rack instance. You can also do mid-tier sharding for multi-tier applications. Okay, you can have a topology server with a sharded database information, blah blah blah. Okay, so this was on 18C. If you really see 19C, further enhanced functionality of sharding. You can have multiple table family support for system managed sharding. 18C only one table family could be supported. 19 support multiple table families. And if you see for multiple PDB shard, 19C can have more than one PDB in a CDB. You can have unique sequence number in 19C. Multiple shard query on Oracle active data guard standby and propagation of parameters. So that's the 19C. So what we just saw was what is sharding and how it is implemented in Oracle at a very high level. What is a high level architectural? Different versions of Oracle, how they're enhancing the sharding concept. Okay. Now going back, as I always take in a session, is to really look at Wikipedia, what it talks, because that gives you a generic view. So we always encourage the learning should be very generic and the implementation can be very specific, right? So what does the Wikipedia talk about a shard or a database architecture? A database shard or simply a shard is a horizontal partition of data in a database or a search engine. Each shard is held on a separate database server instance to spread load. So this is what we also heard from what Oracle was telling. So horizontal partitioning is a database design principle whereby rows of a database table are held separately rather than being split into columns. Okay, each partition forms part of a shard which may in turn be located on a separate database server or thing. Okay. Some of the disadvantage I think we never speak about is a heavier reliance on interconnection between servers, increased latency when querying, data or index are often only sharded one way. These are some of the things which you can really, and you can really see for every drawback there have been custom rules, custom way they have built it across the new products. So that's what Wikipedia talks about. Some of the implementation is also spoke about, like Altibase, the HBase, Apache HBase provides automatic sharding. The Azure SQL database, Elastic database tools enable the data tier of application scale. Or I'm just reading out few of the very interesting implementation. Couchbase is another example. Elasticsearch, which is the enterprise search server, provides sharding capabilities. Hibernate provides for shards. You can see that MongoDB allows sharding from version 1.6. MySQL includes sharding capability. Oracle sharding we just saw. You also have something like as a vault, which is a cryptocurrency that drastically reduces data user need to join the network, also uses shards. Okay, so that some of the disadvantage and etymology is also given. So that's the Wikipedia for you. Now let's look at from a MongoDB how they really look at. So we all know MongoDB is basically a NoSQL thing. So how MongoDB is looking at sharding, because you might see a slight difference the way the approach is, but the concept is same. So what MongoDB talks about is sharding is a method for distributing data across multiple machines. Never changes. MongoDB uses sharding to support deployment with very large data sets and high throughput operations. So what that means is database system with large data sets or high throughput application can challenge the capacity of a single server. So for example, high query rate can exhaust the CPU capacity of the server. So working set size larger than the system's RAM stress the IO capacity. Okay, so that is where the sharding comes. You can have two methods of addressing system growth. One is vertical scaling, second is horizontal scaling. Okay, vertical scaling increasing the capacity of a single server, which we are not talking about here. Horizontal, dividing the system data sets and load over multiple servers. That's what we are trying to talk about briefly. So MongoDB supports horizontal through sharding. So there is a shard cluster. So you can see here a MongoDB shard consists of the following component. It's got a shard, it's got a Mongos, and it's got a config servers. You can see it here, right? It's got so what is a shard? Each shard contains a subset of the sharded data, which you can see it below, and then each can deploy the replica set. Mongos act as a query router, provide an interface between the client application and the shard cluster. In MongoDB 4.4 can support hedged reads to minimize latency, and then you have a config service to store metadata and configuration setting for the data. Shard keys, you can see MongoDB uses the shard key to distribute a collection document across shards. That's very interesting. You have the shard key index, shard key strategy, okay, and you have a lot of information which you can go through. Key advantage which MongoDB talks about, read writes. So since there's a distribution of read write, there will be performance, storage capacity, high availability. So before you do sharding, please do careful planning execution. Once a collection is sharded, you cannot provide no method to unshard a sharded collection. So some of the things which you should see from an architectural perspective. Okay. So that's what MongoDB talks about. It talks about zones, chain streams, transactions, blah, blah, blah. You can have a look at it. One of the questions which you really get is difference between sharding and partitioning. Okay, sharding and partitioning are both breaking up a large data into smaller subsets. Difference is that sharding implies the data spread across multiple computers, while partitioning does not. Okay, so partitioning is about grouping subset of data within a single database instance. So that clarifies, like, sharding will be more effective in terms of the performance compared to partitioning, where you still has the load on the single server. There's another question which is a connected question. I'm just trying to pick those things. We'll go detail later. It's about blockchain. So sharding is a technique in blockchain that seeks to achieve scalability within a blockchain network. The process of sharding seeks to split a blockchain network into separate shards that can contain their own data separate from other shards. Finally, another question which you will have is difference between replication and sharding. So replication creates additional copies of the data and allows for automatic failover to another node. But what sharding does is it allows for horizontal scaling of data by partitioning data across multiple servers. So these are some of the things which I want to really brief in this session. Hope it was useful, and the way you should think these concepts like sharding, replications, clustering, fault tolerance, all these things, or basically it should be part of your use case, non-functional requirement, so that you really can look at a list of concepts, list of innovations, list of design patterns which are available, and then based on your applications you should know, mix and match that. Okay, there's no fixed one set rule which fits all for any of the application globally. Thanks for watching.